Using inverse trig to find angles in right triangles. All right, so in the previous video, we talked about solving for theta when we had a basic equation like this and that we knew theta was acute. Well, if theta is acute, that's good news for us because in a right triangle, there are two acute angles, and they're the only angles we really care about in the right triangle. So if we know how to solve a basic trig equation, if we can solve for theta, then we're able to do that with right triangles and find angles in right triangles when we previously couldn't. So I've written these all out for you here. Technically, as long as we know that theta is acute, we could do something like take sine inverse on both sides. These sine and sine inverse would cancel, and you're left with this theta is equal to sine inverse of opposite over hypotenuse. So I'm going to be jumping straight into these definitions as opposed to writing it like this and then taking sine inverse on both sides, just because it's quicker. So still our SOHCAHTOA, just that theta is equal to the inverse trig of whatever ratio it is. So here's some examples. Find x in the following triangles. Round your answers to the nearest tenth of a degree. So here we have angle x. This is the opposite side. The opposite side is 12. This is the hypotenuse. The hypotenuse is 17. We have O and H, which is SOHCAHTOA. So we have theta is equal to sine inverse of opposite over hypotenuse, 12 over 17. Maybe I'll write out real quick, just so in your notes you put this down. Put that down. Write it down because it's good for your brain. All right. The opposite side is 12. The hypotenuse is 17. So on your calculator, you do sine inverse of 12 over 17. And this should spit out at you the number 44.9. Once you round it to the nearest tenth. 44.9 degrees. Boom. This would be a great moment to pause the video and try these other problems out. I'm going to do them on the video, but it would be great to take a moment and try them. I'm giving you a moment to pause. All right, let's go. So for this next triangle, we have an adjacent side. This is adjacent to x, so the adjacent is 13. The opposite is 24. We have O and A, so that's going to be tangent for the TOA. So theta is equal to tan inverse of opposite over adjacent. I'm not going to write down that first step anymore, but you are doing the same thing you did here, where it's tan inverse of opposite over adjacent. 24 over 13. And if you plug that into your calculator, you should get, oh, and I'm saying, you know what I should do? I shouldn't say theta. I should say x, because this angle is not named theta, it's named x. So we'll just rename him x. It doesn't matter. The answer is the same. This is equal to 61.6 degrees. For this last one, we have an adjacent side, and it's 8. We have a hypotenuse that is 18. So we have A and H, A and H. And that's SOHCAHTOA, cosine. So x is equal to cosine inverse of adjacent over hypotenuse. So 8 over 18. Plug it into your calculator, and you should get 63.6 degrees. Again, this right here, this was tan inverse of opposite over hypotenuse. That's how you solve, not hypotenuse, adjacent. That's how we solved for x there. This was cosine inverse of adjacent over hypotenuse. So not so bad, right? Um, we can now use this to solve entire right triangles. All we need are two sides of a right triangle, and that's enough information for us to solve for all the angles and all the side lengths. So that's what we'll be doing in our next video. I'll see you then. Bye.